In this lesson, we're going to look at Pythagorean's theorem, similarity, and floor plans. And Pythagorean's theorem is side squared plus side squared equals the diagonal squared. I know a lot of people have thought of it as a squared plus b squared equals c squared, but if we don't remember a's, b's, and c's, then we're not sure where to put them. And so this is why I like to use side squared plus side squared equals the diagonal squared. And just to recap, the diagonal is always the side opposite the right angle, and this theorem only applies to right triangles. And so this is the 90-degree angle. The diagonal is the one that is always across from, and so this is our diagonal. And the reason why Pythagorean's theorem works is the side, so this triangle's length, each one of these lengths is related to the areas associated with the squares that are built to cover those angles. So if we look at two examples here, one where we're going to find the diagonal, and so in this case the diagonal length is missing here, so this is what we don't know. And so we know that the area of the squares combined together, so if we add these two together, that's going to equal the area of this bigger square, and then we can find this length by taking the square root of that value. So we know that this side right here is 40, and since it's a square, we know this is also 40 meters. So 40 meters times 40 meters gives us 1,600 square meters. And then 14 times 14 meters gives us 196 square meters. And so the length of this, the length of this diagonal is going to be one of the sides of this particular square. And so we have 1,600 square meters plus 196 square meters. That's going to equal the diagonal square. I can spell diagonal correctly. Let's try this again. Yeah, I just, whoops. And so when we combine these together, we get 1,796 square meters. So that is the size of this triangle, or I'm sorry, this square right here. And because this square has 4 equal sides, we know that one of those sides is just going to be the square root of that diagonal, or that area, excuse me. And so if I take the square root of 1,796 square meters, and remember that now we're going to have the diagonal length, because when I take the square root of that squared, I'm going to end up with just meters. And so I'm going to go over to my calculator. And again, if I am looking at my calculator, if I turn it sideways, I'm going to see a square root. So I can take the square root of 1,796 if I'm just using my calculator, and I end up with 42.3792, and so on and so forth. This time it says to round to 2 decimal places, so we're going to go ahead and do 42.38 meters is this diagonal length. And so that's how we apply Pythagorean's theorem. Now here's a situation, the other example here is where we don't know the length of one of the sides. So this is where we're missing a length. And so we know the big square, so again this is our right angle, and so we know this is our diagonal, is our 225. So we know that one of the side squares, one of these squares is equal to the diagonal square minus the other side, its area. So the area is 225 square meters minus 121 square meters is going to give us the area of this square right here. Remember, this is inside, that's that square. So that particular square's area is going to be 104 square meters. And in order to find just what that length of one of the sides, we're going to take the square root. So the side length is equal to the square root of 104 meters squared, which is going to equal, now when we do this one, let's just talk real quickly about rounding. So I'm going to take the square root of 104 and equals, and so if we're rounding to 2 decimal places, we have 10.198. 2 decimal places is this 9. So the 8 is going to force the 9 to become a 10. And since this becomes a 10, that means we're going to have another one in the ones place. So we get 10.20 is our rounding there. We get 10.20 meters when we round. So I'm going to let you guys in your teams go ahead and come up with the answer to this perimeter question. And again, this time we're going to have to find the length of that diagonal first so that you can add up all of the sides. So now, many times we talk about this idea of the distance between, as the crow flies, so the distance across rather than us driving in blocks. And it says each block is half a mile. Well, it doesn't say that we have to answer the question in terms of blocks or in terms of miles. So we can just count up here 1, 2, 3, 4, 5, 6. So we have 7 blocks. And then 1, 2, 3, and we have 4 blocks. And we can answer this question in terms of blocks. So 7 squared plus 4 squared is going to equal, in this case, we have this big X squared. And so we're going to end up with 65 square blocks is equal to our big X squared. And when we take the square root, we're going to end up with 8.06 blocks is the crow's distance. Now we could do this in miles instead. Didn't specify which one. It says each block is half a mile, so if we have 7 blocks, that means we have 3.5 miles. And we're going to square that. Instead of 4 blocks, that means we have 2 miles. We square that. That will also give us our X squared. And we have this 16.25 square miles. And when we take the square root of 16.25, we're going to end up with 4.03 miles is that X, or the crow's distance. And if you think about it, again, this is, every block is half a square mile. So if we wanted to, we could have, what we do is just scaling. We could have divided our blocks by 2 to end up with how many miles we want. And this is just called scaling, which leads us to this next idea of similarity. So similarity is this idea, or proportional reasoning is a process of maintaining equivalence between 2 proportional objects. And a proportion is a fraction, so it's a relationship. And so if we look at this particular, these triangles, we see that 9 and is B, and B prime is what they call that. So let's get out of that. Let's see if that'll work now. So we're going from big to small, so that means that we're going to divide by 9 over 6, or 1.5. So if I want to go from 12 to C prime, so C prime is going to be 12 divided by 1.5, which is equal to 8. Now if I wanted to go the other direction, so now I have small to big. Instead of dividing, I'm going to multiply, so I'm going to take 4 times 1.5, which means A is going to equal 6. Right? The other way we can do this is by thinking about it in terms of, again, scaling. So we're making either things larger or smaller depending on how we go about this. And so we want to create this idea of a scale drawing. So if each square is worth 5 feet, then 5 squares is going to equal 25 feet. So anytime we're looking about scaling, whether it's scale drawings or even maps, we do this a lot. So if we count how many squares we have here, 1, 2, 3, 4, 5, 6, 7. So if this was the side of a room, this would be 35 feet. Remember that one line represents feet, 2 lines represents inches.